In this video, we're purely going to look at the different structures of silicate ions. The basic building block of all silicate structures is this tetrahedral unit composed of a silicon atom surrounded by 4 oxygens. The different structures result from the different arrangement of these tetrahedral units. So we can have the tetrahedral units just on their own. They can also be arranged in chains or rings. Lastly, we can see structures in which these tetrahedral units join together to form a sheet structure. So these are the different structures that we're going to have a look at here. Before we look at this, there's a key point that you need to keep in mind in terms of how the tetrahedral units join together. And that is that the silicon atoms always join together via an oxygen. So the bonding will always look like a silicon bonded to an oxygen, which can then go on and bond to another silicon, as opposed to 2 silicon atoms bonded directly together. So whenever you're drawing these structures, if you find yourself wanting to join 2 silicons together like that, or you see that you have, you just need to take a step back for a moment and reconsider the structure you're drawing, because you should never end up with a silicon bonded directly to another silicon. Firstly, we're going to have a look at a few structures which exist as individual ions. The simplest of these structures is one tetrahedra. And we can see when we look at this structure, it's composed of 1 silicon bonded to 4 oxygens, and each of those oxygens has a negative charge. Because of that, we get the formula of SiO4 4-. Another structure in which it is an individual ion is a structure that composes 2 tetrahedra. Now, as these structures get bigger, I'd like you to take note of the process I use to draw them. So if you follow a methodical process when you're drawing these structures, you're more likely to be able to build them up. Whereas if you just look at it as a whole large structure and try to draw it, you can get lost. So 2 tetrahedra mean that we're going to have 2 silicons, each surrounded by 4. So the first thing I want to do is draw the core part of the structure, which is the 2 silicon. And I do this in a similar way that I draw a tripolyphosphate ion. So if you recall from when we do that, we'll go oxygen to silicon, down to oxygen, back up to silicon, down to oxygen. In this case, we're only doing that twice because we only want 2 tetrahedra. Once we've done that, we know that each silicon needs 4 oxygen. So we just add in our extra oxygen, and then we have a look, and any oxygen that doesn't have 2 covalent bonds coming out of it, we need to add a negative charge. So here, 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 and here. So then if we want to deduce our formula from this, we can see we've got 2 silicons. So we've got Si2. We count off our oxygens, 1, 2, 3, 4, 5, 6, 7. So it becomes O7. And then if we count our negative charges, 1, 2, 3, 4, 5, 6. 6 minus. The last example we're going to look at for individual ions is actually silic ions. So that means they form a ring, and the ring in the silic silic ions contains 6 tetrahedra units. Now, as you guys mentioned in class the other day, one thing you get good at in chemistry is drawing hexagons. From this point on, you're going to be getting lots of practice at that. So basically, our silic ion is based on a hexagon shape. Now, something I want to point out at this point is just keep that in mind. So when you're drawing this ion, you're aiming for a hexagon-like shape. And along the sides, what you're going to have is an oxygen in each of the corners and a silicon in the middle of each side. So if you keep that in mind when you're drawing it, it can be easier to build up this structure. So with that in mind, I'm going to draw the first side. Then I'm going to do the second side, third side, base, and the remaining 2 sides. So I've built up that ring-like structure. Now we know that each silicon needs 2 oxygens, so we can go, 4 oxygens. We can go in and add the additional one. So we can see this one needs 2. And as we go around, we'll find that each one needs 2 oxygens. Lastly, any of the oxygens that only have 1 covalent bond need a negative charge. So all of those oxygens that we just added need to have a negative charge. Just going to fix that bond up there. There we go. All right. So from this, we can determine the formula of the silic ion. So if we go around, we've got 1, 2, 3, 4, 5, 6 silicon, so Si6. If we go count up our oxygens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then if we have a look at our negative charges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's got a 12 minus charge. The next group of silica ions are chain polymers. So that means they are continuous, ongoing structures. And we'll have a look at a couple of examples. The first one we're going to have a look at is a single chain. So the core part of this chain is going to be just repeating tetrahedra unit. It's going on and on with each silicon joined via an oxygen. So again, watch how we build up this structure so you can try follow the same method to draw. So we're going to start with a silicon. We go down to an oxygen, up to a silicon. And this is the basic structure of our single chain. All right. You'll notice how on the end here, I've left these open. That is what we need to do to signify that this is actually a polymer. So it's an ongoing structure. It doesn't stop here. So previously, when we drew the individual ion, which contained 2 tetrahedra, we stopped at the end of the structure and put a negative charge on the oxygen because they were discrete little packages of 2 tetrahedra. Whereas this chain continues on in both directions and we're just drawing a section of it, which is why we just keep these open bonds at the end. You could draw a larger section of the chain or a smaller section of the chain. Just need to make sure you keep the ends open to clearly show that it is a small section of a larger structure. Each silicon again needs to have its 4 oxygens. So we can see here this has got 2 bonds coming off of it, which would go to oxygens. So we need to add 2 more. And that's the same in the case of all of these silicons along the chain. And then we add negative charges to those oxygens which only have 1 bond. Now we'll treat this structure the same as we treat other polymers, and that is to get the formula we need to identify the repeating unit. So if we just start in front of one of the silicon units and we travel along until we see the structure start to repeat itself. So as soon as we get to this silicon here, or repeat, so we just identify here, that is our repeating unit. And we can see in our repeating unit we have got 1 silicon, we've got 3 oxygen, so it's SiO3, and we can see 2 negative charges there, so it's SiO3 2 minus as the formula for our repeating unit in that polymer. The next structure we have a look at is a double chain. So you can think of that in a similar way as the previous structure, but instead of having 1 continuous chain, we've now got 2, and they are cross-linked together. So just very roughly, if you have a look here, we've got our 2 chains, and then they're going to be linked together. Now, it's important to keep that overall structure in mind. What's also important is to keep in mind what forms the length of each of these up and down parts of our chain. Now in this case, it's going to be a silicon at the top and the bottom with an oxygen in the middle. So we're going to build our structure up like that. Okay, so let's give this a go. So we're going to go silicon to oxygen to silicon, oxygen to silicon. Now I could keep going on, but I'm going to stop there. Now what I can do is I can start to draw my second chain down the bottom here, following that same pattern: silicon, oxygen, silicon, oxygen, silicon. And then our 2 chains are cross-linked together through an oxygen. So we're going to go silicon, oxygen, silicon. And so we've started building the basics of our double chain structure. Just take note again that the end of each structure is left open because it's going to continue on in both directions. What we need to do now is ensure that each of the silicons has 4 oxygens around it. So we can see this one here. Silicon has 2 oxygens. Here it's got another bond going off, which would go to an oxygen, so it would be 3, so we just need 1 more. This one at the top here, it's got 2, so we need to add 2. This one down here, add 1. This one we're going to add 2. And then we get to these ones. What you'll notice I've done here is we can see we've got 4 oxygens around the left hand side of the ring here. When we get down to these 2, each of these need 1 oxygen. So we can just go 1, 1. We can keep doing that through the structure. So these ones need 2. 1, 1, 2. We can go back through and double check, but basically all of our silicons should have 4 oxygens around them. Now, in these larger structure, it's important that you can identify the individual SiO4 tetrahedra units. So for example, if we have a look, we can see one here. Basically, it's that structure around every silicon. You can see another one here. It's important if you're asked to identify them that you circle and label them. Now, the other thing you need to be able to do in this structure is identify the repeating unit, and that way you can get the formula. So in this case, I like to pick a point which is quite easy to visualize and find. So for me, it's those vertical links between the two chains. So I'm going to start my repeating unit there and just scan along the structure until I see that part start to repeat itself again, which I can see here. So I'm going to end my repeating unit there. Now you'll notice because I started after the oxygens and before the silicons, I'm going to end after the oxygen and before the silicon. The last thing we want to do is count up what is in our repeating unit to give us our formula. So we've got 1, 2, 3, 4 silicons. Si4. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 oxygens. And 1, 2, 3, 4, 5, 6 negative charges. So it's Si4O11 6 minus as the formula for the repeating unit in our double chain polymer silicate ion. The last structure we're going to have a look at is a large network sheet structure. So basically you can picture this as a large network of hexagons all joined together, and just remember that in this case the side of each of these hexagons is a silicon in the corners with an oxygen along the side. So we can use that to start building up our large structure. So let's have a look. We go silicon, oxygen, silicon. I might just adjust that a little bit. So we can see we've got the basis of our first hexagon there. So we can just do that again. And I'm just going to leave the structure there, but you'll notice I've left the ends open because we know it's going to keep continuing on. Also, each of those silicons would continue on in that way. So now we need to continue building the hexagon structures below that line of hexagons. Okay, so we can see we've got the core structure there. What we need to do now is have a look around each of our silicons and make sure it's got 4 bonds going to oxygens. So we can see this one needs another one, as to all of these ones. So we're essentially just adding 1 oxygen to each of them. To keep this organized, what I like to do is I've gone around that ring, I've got my 4 oxygens on the left hand side there. If I come across to this backbone bit here, I can see this one and this one both need 1 oxygen as well. So I'm going to put them into that ring there. So now, all along that chain of rings there, we've got the 4 oxygens around the left-hand side of the hexagon. When we come down to here, this next, what looks like row of hexagons, we'll notice that that silicon has already got 4 oxygens, already got 4 oxygens, already has 4 oxygens. So we don't need to add the oxygens. If we get down to this next row of silicons, we can see this one's only got 3, so we need to add 1. To help keep it organized, rather than putting that up into this row of hexagons here, I'm just going to put it down here, and I'm going to go around this row in the same way. So within our large structures, basically what you end up with here is a row of hexagons, each with the 4 oxygens with a negative charge around the left-hand side. Then you have a row of hexagons with no oxygens in them, and then a row of hexagons with the oxygens again. That's just a way of drawing it to help keep it organized. Now within this large unit, again, you need to be able to recognize the individual tetrahedra. So basically there is one around every silicon, but just as an example, here we've got 1 tetrahedral unit with the 3 oxygens along the bottom. This is another example of a tetrahedra in the other orientation with 3 oxygens along the top. Lastly, we need to identify a repeating unit. So I'm going to pick a part in the structure that I find easy to identify. So again, I'm going to look here and along there. And I'm going to just continue through that structure until I see it repeating itself. So that's at this point here again. So I'm going to stop there. I just want you to take note that at the top and the bottom of the hexagon here, see up here I haven't included an oxygen at the top, so I have included an oxygen down the bottom. So if we count up what we've got in the repeating unit, 1, 2, 3, 4. Actually, you'll notice I've drawn that line there pretty poorly, because that should stop in front of those silicons there. So I've got Si4, count up our oxygens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. O10, and our negative charges, 1, 2, 3, 4. 4 minus is the formula of the repeating unit. Now, sometimes you may, this is the most obvious one to go to, but we can also take a smaller repeating unit. If we just have a look at this structure here that we see repeating through as well. And in that case, we've got SiO5, 2 minus. So I recommend you practice drawing each of those different structures. As you get up in complexity through those structures, I recommend you practice drawing them several times until you have some sort of methodical process that you can follow to build up that large structure. So making sure you break it down in your mind into the smaller patterns or components that you can see within the structure.